Algebra 2 kiddos, we are going to start this year off light and easy with what is hopefully just mostly a review from Algebra 1, but if you're rusty, we're going to go back through everything with functions. So we're going to talk about relations versus functions and then different ways to evaluate functions. So first off, some definitions. A relation is a subset of ordered pairs. So any relationship, this can be numeric, it could be words and numbers. One example of this could be if I have one set of data that is names. So if I've got Smith and John, and maybe these are teachers, students, that's up to you to determine. And then on the other coin, I have some different classes like art, math, and history. I could make a relationship between these sets of data saying Smith takes art class and math class, and John takes math class and history class. This is just one example. You could write your own relationship from words to words and numbers. It could be somebody's name and heights. It could be names and birthdays. It's just any relationship between two sets of data. So if one set of data is names, one is classes, there could be a relationship there. A function is a relation, but it has a very special rule. You can only have one input for each output, or one x for each y. So an example of that could be on a graph, or if we're just looking at a set of ordered pairs, here is 1, 9, 3, 2, negative 2, 1, 3, and 0, negative 4. As long as none of my x values are repeating, then it could be a function. So notice I've got 9, 2, 1, 0. None of my x's repeat, so that could be a function. But do notice I do have a repeating y value. That is okay. Y's can repeat, x's cannot. So how can we determine if something is a function? Well, one is by if we have a set of data like this, checking our x's, make sure none repeat. But how would we check it graphically? We have a special way to do this, and that's with something called the vertical line test. And what that means is we are going to draw a vertical line up and down through the graph and see how many times it touches. So if I do that first for this graph on the left, notice it touches once, twice. This means it fails my vertical line test, and therefore it is a relation, not a function. When it fails the vertical line test, it's a relation. Now, if I draw a vertical line through my graph on the right, notice it only touches once. So this passes our vertical line test, and it is a function. So again, vertical line test is how we determine if a graph is a relation or a function. Touches once, it passes, touches twice, it fails. Now we're going to be evaluating some functions. One way we can do this is by hand or algebraically. And when we're doing this, one thing that's important to consider is what is the problem asking? Are we given an input and looking for an output? Or are we given the output and are we looking for the input? So we need to evaluate carefully. So remember, x is our input, or f of x, which sometimes you'll see as y, is our output. So looking at this first one, given f of x equals negative x minus 5. This is my function. Solve for x when f of x equals negative 3. Now, what we're given here is if f of x equals negative 3, this is the output. I'm given the output, and I'm being asked to find the input. So I'm not going to be plugging in negative 3 for x. I'm going to be plugging in negative 3 for f of x. So negative 3 equals negative x minus 5. This is just a two-step equation. Order of operations, I have to add first. And then to get rid of that negative, I need to either multiply or divide by negative 1. And so x is negative 2. So what that means is f of negative 2 equals negative 3. When my input is negative 2, my output is negative 3. If I were to graph this function, somewhere on my graph I would have a point negative 2 comma negative 3 on the graph. Okay, on to the next one. Given h of x equals 5x plus 2, find h of negative 6. For this one, we are given the input and asked to find the output. This is probably what you're more used to seeing. And so everywhere I have an x, I'm going to be substituting in that -6. So h of -6 is 5 times -6 plus 2. Order of operations says that I multiply first, and then I can add. So h of -6 is -28. When my input is -6, my output is -28. If I were to graph this somewhere on my graph, I'm going to have an ordered pair at -6, -28. All right, and then last one on this front side, I've got yet another function, g of x equals 3x squared minus 10x minus 9. Find g of 4. Again, I'm given the input, and we're looking for the output. So everywhere I have an x, I need to put 4. And that's going to happen in two places here, because I've got two x's in my function. So 3 times 4 squared minus 10 times 4 minus 9. Order of operations says I need to do my exponents first. And then I can multiply. And so when my input is 4, my output is -1. Somewhere on my graph, I'm going to have the point 4, -1. Now, what format are each of these functions written in? When we're having f of x, h of x, g of x, you could have k of x, anything like that that's not saying y equals. This is called function notation. So if you see the word function notation, you should have something of x. So x is in parentheses instead of having y equals. That is called function notation. All right. And then the last thing we're going to talk about is evaluating functions from a graph, because we can do it by hand algebraically. We can also do it graphically. So remember, x is our input, or the x coordinate. F of x is our output, or the y coordinate. So when you're asked to find f of x, you're looking at the y value that corresponds to the given x value. So looking at this first graph, if I want to find f of 5, this means when x is 5, what is y? So on my graph, I'm going to go to where x is 5, and I'm going to find on my graph that point. So this is the point 5, 5. So my y value is 5. So f of 5 is 5. That's it. You're just looking for your y coordinate. Let's do that one more time. Find f of 9. So this is saying when x is 9, what is y? So I'm going to go to 9. Here's that point on my graph, 9, 8. So f of 9 is 8. Now this isn't on the notes, but I'm going to add in this to take it one step further. Because remember, we can find an input given an output as well. So if instead of saying find f of 5, what if we were asked to say, what is x when f of x equals 1? For this type of situation, I'm being given my output, my y value, and I'm looking for the input. So I'm going to look when y is 1. Look, that happens in two places, at x equals 0 and 4. Let's do that on the other one as well. What is x when f of x equals -2? So I'm going to look where y is -2. And again, this is happening in more than one place. And those two x values are -5 and -1. So we can evaluate it graphically both ways as well. Just like when we had the function, we could find the input given the output, you can do it on the graph as well. So just something else to think about and consider with functions. This has set you up well to do your first homework assignment, and you can refer to the PowerPoint and Canvas if you need further clarification.